If you've automated a few things thanks to Claude Code or Cowork, and you're wondering what might be next, this video might just be for you. I'm going to walk through a project which I've made an open source, which is going to show you how to use Trigger.dev to make a more robust agentic workflow. The project is this stock research assistant. What we're going to be able to do is enter a ticker and a research focus. From there, we'll run this system by pressing the run button. The agent will come up with a plan, which is only going to run if it's approved by us, showing what a human-in-the-loop workflow looks like. If we approve the plan, we're going to see multiple agents fan out and collect data through a few different methods. And if one of those happens to fail, it's not going to break the whole setup. In fact, thanks to Trigger.dev, we'll actually be able to retry the failures, and if we still can't progress, it's going to actually move on anyway. And that kind of durability can't be understated. If you think about any AI skills or projects that you've made where something small breaks and all of a sudden you lose everything, well, that's not going to happen here. If you want to follow along, come over to this GitHub URL and paste that in your favorite coding setup. You will need to add in some environmental variables. Specifically, you'll need a Trigger.dev account, and then in this case, I'm using both Anthropic's API and a financial datasets API. The financial dataset API helps me get a variety of financial pricing and information that's going to be needed for our search. If you were to make a system that wasn't about finances, you'd end up putting your own APIs in here. Okay, so let's jump in and start researching a company. So we're going to enter meta, and then we're going to come up with a research focus. So we might change this just a little bit for this example. We're going to hit run, and this is where our main orchestrator is going to come up with a plan. And that plan needs human approval. And we've done this on purpose. Essentially, this orchestrator has correctly identified that there are quite a few worker tasks that need to be done. And we can see it's split it up into those tasks based on different API calls that it might want to make. So in this case, there's 8 different calls that we're going to make. And this human-in-the-loop pause essentially gives us just a small break where we can confirm if this is what we actually want to do before making API calls. If we view this inside of Trigger.dev, we can actually see the primary task that is running. And we've got it called stock research run. You can see here that we've got the task running inside of Trigger.dev. We can actually see that we started this task 12 minutes ago. So I paused the video and came back, and it's been running or waiting for 12 minutes. And I did this intentionally to show you how a workflow can work where you are wanting to or relying on a human to intervene. Now, if we jump into the code and see how this looks like, I can find the stock research task. We can see that it's got a max attempt of 2 and various kind of timeouts. But what I actually want to find is the waiting for approval. So the reason it's waiting for a human is that we are waiting for this token to be approved for it to continue to run. And in this case, we've actually got a 30-minute timeout on this specific task. So if we let this run for another 15 or so minutes, then it will actually auto-reject. Okay, so let's come back here and let's actually approve this plan. So now that we're approving the plan, we can actually see the child tasks fan out in order to complete them in parallel. Some of them happen very quickly, like institutional flow, and then others like KPIs and guidance is taking a bit longer. And that's one of the benefits of running this system this way is we're not waiting on a chain of API calls to all go through one at a time in a direct chain. We're fanning out using essentially sub-agents. So if we come back to Trigger.dev, we can see that this was the initial start of the run, and from there it used subtasks to fan out and complete these 8 child tasks at the same time, where most of them took a couple of seconds to complete, and then the longest actually 13 seconds, which ended up being a failure, but that was intentional for this demo to show you that even though there was a broken API call, we were still able to ultimately complete the task and get a report, even if there was a failure. And what's great is we can click into it and see how this error actually transpired. So we can see that it ran this task 3 times. We can see the first attempt took 1.5 seconds, failed. then waited 1 second before attempting the task again. It failed again. We waited 1 second and it attempted it a third and final time. And we can see we got the error here. But again, I want to highlight that Trigger did its job here and it essentially triple checked that this error was in fact an error. If it wasn't an error, and maybe it would have been successful on its second attempt, in which case that's great. And that's something that is going to be different from a workflow that you might have made where it doesn't know how to handle errors and doesn't know how to retry or how many retries should happen. That's a benefit to something like Trigger.dev. So just to recap, in the runs, we had the main orchestrator run. From there, it fanned out into the 8 subtasks. These subtasks were listed in the plan here, and we can see that in our code. So we can see what the approved research function looks like. Inside of that, we've got this batch items, which is a promise all. So that means that essentially this will only resolve once all the promises are returned. In some cases, like we just saw, that still might be a failure, but we are getting that promise returned. And if we scroll down, we can essentially see that different dimensions are the different API calls here. So things like the fundamentals trend, earning surprises are all different dimensions. And given how we've set this up, we are actually able to stream the output. That means as the outputs come in, we are seeing their success or failure and ultimately building this research report live. And in our UI, we're kind of capturing that success and failure through this metadata setting, which is essentially resolving the status of these child tasks, but it's essentially duplicated by what's actually happened here. If we wanted to actually audit this and we didn't have this specific UI built, we could actually just come back to the Trigger dashboard and come in and see what was going on for each of those dimensions. So we can actually see that in this case, the dimension label of this specific run was MDNA narrative. So if we come back here, that was this task. So this was just a UI representation of what Trigger actually already has for you. And now we can ultimately look at what it generated. So we can open up the note that it's created and ultimately what its summary of all the research was. So in this case, it was the quality of earnings and cash flow analysis. And through all of that data collection, it's come up with this report. And you might have noticed that on the tasks page here, we do actually have a cron job set up, which is essentially a scheduled run of our primary task. So in our code, we've got this function here, which is essentially that cron job. We can see that it's a schedule and we're able to configure this inside of our environmental variables, but it's got some default settings as well. So ultimately, in this case, it's going to run at these default times and time zones. And we can actually preload it with a set of different tickers as well. So if we looked in the env example, we've got some optional scheduled watch list information. So in this case, it's going to check for NVIDIA, Microsoft, and Apple. It's going to focus on overnight risk, valuation, and filing changes. And it's going to run at 10 o'clock every Monday through Friday in New York time. So in summary, we've got our kind of primary parent task here, which essentially owns the planning, the approval process, the fanning out of the child task dimensions. These child tasks all essentially own one different type of API call or task, which is then sent back to the parent orchestrator. So we've got our front end, which waits for the human approval thanks to the wait.forToken. The task is started and we see batch trigger and waits. So that's the fanning out of the 8 different subprocesses, which will only move forward once it actually returns success or failure for all of those 8 tasks. In our example, they were reasonably close together, but in some cases you might have tasks which take 1 second and tasks which take multiple minutes. And that's definitely where this would become pretty helpful. We saw that some tasks failed and we were able to see how Trigger.dev was able to handle retrying those failed tasks. And while all of this was happening, we were able to stream the outputs, and ultimately, once it was complete, we were able to inspect the finished report. And if we didn't want to run this manually, we saw how we could set it up as a scheduled task that runs essentially 5 days a week on a variety of stocks and bypassing the initial wait for approval. So hopefully you enjoyed that example of using Trigger.dev for a slightly more complicated, but definitely more robust agentic workflow. I think it's definitely worth you either cloning this repo or just trying to start a new project yourself. Start with a basic example like this before you build something more complex. If you're looking for something more complex that still uses Trigger.dev, you can check out this other video that I made which launches sandboxed instances of something like Claude Code. See you next time.